All right, good morning, everyone. Welcome to the Subspace Storage API Sync. Today, we're going to talk about the progress we've made on the Relayer app and backing up archiving the Kusama network on Subspace. We'll start off with Serge giving your updates, and then Nazar, we can talk a little bit more about what you've been doing with the Kusama file backup and figure out what we can do next. So, Serge, if you want to take it away.
Thanks. Sharing my screen. All right, so let me walk you through my pull requests that were submitted since our last meeting. So one was, I have two small ones, relatively small ones. One is adding fetch parablock timeout for basically fetch parablock method. Oops, sorry. Let's see. Yeah, so this is a parachain class, and I have added this function, basically a wrapper, and we add timeout. And when time is out, we actually cancel the request. And here we use it. So basically it was fetch before, and now we have fetch with timeout. And yeah, this is a minor fix. There was an error with a typo with a file path. And that's it for this one. Any questions on this one?
Yeah, last time we had talked about the ability for the blocks to get written out of order with the timeout. Did you account for that at all?
No, this is timeout for requesting parablock. So the order is the same, but if for some reason we cannot fetch the block, we just skip it. Because sometimes like RPC API doesn't return anything. And we have retries, but yeah, we have currently 3 retries. But if 3 retries didn't have any result, we just skip it for now. And yeah, this is something I wanted to discuss. How do we handle it? We can collect like an array of hashes of blocks that were skipped and maybe refetch them again in a while, or use different RPC endpoint. So there is something to discuss, but yeah, the order should be the same. Like if it's fetched, if parablock is fetched, then the order should be the same.
So it's only if the third retry fails that we'll have a break in the block history.
Right.
Okay, makes sense. Yeah, and I think that's robust enough for now, but we should create a ticket, like a research ticket, to address this and hopefully discuss this at the offsite as well when we get into the relayer section.
Let me do it. Okay, I think good for now. Okay, next one. So last week I implemented a minor optimization so we can have a JSON file in which we store like a record, and in which we store for every wallet address we store a particular feed ID. So we can we don't have to create a new feed every time we restart Relayer. And this is a minor addition, also suggested by Nazar. So basically, we check this JSON file, but we also check if there is this feed ID on the chain. So we ask, there is a method to query feeds palette, and we have a feeds hash map in the palette. So we provide this feed ID if we have it locally. And if it is empty on the chain, that means that we have it only in the local JSON, but on the chain, there is none. So if there is no feed on the chain, we create a new one just as we did before. And that's it. Any questions on this?
Nope, looks good.
Okay. And yeah, so these two were last week. This week I was working on, so this PR was a preparation for the resync on restart. So basically to do resync, we need to store last process block, and we also store feed IDs, as I mentioned before. So to handle this properly, and like I created a separate module, which is basically responsible for storing and retrieving this data, and potentially we can use it to store something else if we need. So I created a new class. It's called state, and we provide when we instantiate it, we provide a folder where we have those JSON files for feeds and for last process block. And after we create this state instance, we pass it to the target class and the source class here. So they both have access to the state, and I will show you how they use it. And this is just updates of types. This is a minor. Yeah, this I have added some. Yeah, so here, after we process, we get information about relay block. We store the block number. We get it from the metadata, and we store it using this state module. There is a method called save last process block. I will provide the chain name. In this case, it's Kusama, and the block number of the block which was submitted for transaction. And this is the actual module. It's relatively simple. So yeah, we have a path for last block JSON, this one. And we have a same path for the feeds.json file. And we have currently, in this PR, we have 3 methods. Later, I have added more. So here we have a method to save last process block, and I already showed it before. And same for feed ID, to save feed ID when we create a feed ID. And to get feed ID after when we restart before we send the transaction to create a new one. So basically we read from these JSON files and update them accordingly.
Quick question, Serge. Last process block, does that mean that we've got a notification that the block has been included in the target chain, like an event, or just that we've submitted a transaction to include it in the target chain?
Currently, we save it before transaction is submitted. I think maybe we should do it after transaction is confirmed or added in the block. But this is a little bit difficult because when we send transaction, we don't, so it will require some modifications if we really want to go that way, because currently target doesn't know. So we need to check if it is Kusama transaction, then we save block number. If it's not, then we just send it right away. Yeah, basically one more if statement.
Why is there a difference if it's Kusama?
Because we only store last process block for relay chain. We don't store it for parachains. Because it doesn't make sense. We have like one Kusama block, and in Kusama block, from Kusama block we can get all the blocks that are included, all of the para blocks, right?
Mm-hmm.
So we only depend on the Kusama blocks in this case.
Right, but maybe Kusama block was included, but the parachain blocks were not.
Included where? You mean?
In the target chain, you are still submitting them as separate transactions.
Yeah, but the way currently Relayer works, that we are processing Kusama blocks first, relay chain blocks first, and every relay chain block has associated para blocks. So we are not tracking which block was actually submitted. We are tracking, in this case, Kusama process blocks. If you want, we can extend it to include parachains, but currently I didn't see.
That's what I'm saying. Like, if you are not only archiving Kusama but also parachains, we kind of have to know about them something. We should either store a number or we should query the actual target chain and check like how many blocks we have stored. We already have the counter, so
But we don't have a mechanism currently to refetch or fetch para blocks separately. We only fetch them when we process Kusama blocks.
All right, then make a method that will fetch Kusama block, throw it away, and return you the information about the para block. Like, it is possible.
Yeah, it is possible, but this was not in this scope. So this is something we can add a separate task for that.
No, I get it. I think this is fine for now. I'm just trying to understand how it's working more than anything, Serge. Maybe this is a dumb question, but is this just an optimization to have the state cached locally? Like, or what is it possible to have this relayer be stateless, and just getting the state from the target chain, like the feeds on startup, and not having to save a local state object? Is that strictly necessary, or is that just kind of a convenience here?
It is optimization. Well, in case of feed IDs, it is optimization, because otherwise we have to submit new transactions and it takes time. And in case of for last process block, we need that so we know, so we know which block was processed. So in this case, it's necessary. So feed IDs, yeah.
Theoretically, if you only store blocks, then we can just query how many objects we have, subtract one, and we should know the height of the archived history. And we can do that both for relay chain and parachains and everything. And it's just one RPC call. It shouldn't take very long time.
Maybe.
So I think there's like two things going on here, and I think I understand kind of why you have it this way. So you have what blocks have been, like, so you could have the relayer running. It could receive a Kusama block, and it could submit a bunch of transactions, and then it could fail and restart, and then it could query the chain and say like, oh, well, this was the last block because those transactions I just submitted haven't been included. And then it could resubmit all those transactions. But you're trying to track what has been submitted here versus what has been confirmed on chain. Is that because there's kind of two stages here, right, of this process that could independently get out of sync?
Yeah, but there is more. There is more because if we want to process Kusama from particular block, then we can use this JSON to specify the last process block. Maybe last process block is a confusing name. So, for example, if we were processing blocks and then Relayer stopped working for some reason, and then we restarted, we need to know what was the last one, right? because otherwise it will just subscribe to the new ones, and we will have like a bunch of blocks missing.
And that's where I'm saying that you can just query the state and see how many objects there are in the feed already. Subtract one, and you know what was the last block.
If we started from 0, yes.
Well, this is what will happen eventually.
Eventually, yes, but currently we don't.
Right, makes
Yeah.
sense.
Okay.
It's not true right now.
Okay, cool. I think we beat this dead horse enough. Do you want to move on,
Okay,
Serge?
so no, let me add this quick ticket for this. So instead of storing last processed block, query chain.
And on that, I think there's an additional edge case of even if you query the chain and get the last confirmed object placement, there could be some transactions in the mempool that are already there that haven't been processed.
Absolutely.
Like if it's like a restart,
it's kind of up to you to like figure out if something is still in flight and you need to just wait before restarting. We just have like edge cases on edge cases on edge cases.
Yeah. Shall we move on, or?
Yeah, let's move on. I was just trying to make that more clear.
Okay, so this is a state class, and this one resolved. So this is a target class, and yeah, basically it's just minor refactoring. So we use this module instead of working with a file system from target class, like here. So basically everything, like read files, write files, everything, it moved to the state module. And here, target class just uses it. Yeah. Any more questions on this? Okay. And currently, as I mentioned, I was working on the resync blocks on restart. And I haven't created PR yet, but I will show you what I have implemented at the moment. So yeah, this is a source class, and I have added a bunch of methods here. So first is get finalized header, because we need to know, in order to process like how many, to know how many blocks we're missing, we need to know what was the last process block number and what was the finalized block number. So for this, I created this method to get finalized header, and from header we extract, we get the number value, and this is a get last process block for this particular chain. So we go to the state and we provide the chain name, and we get the block number. And this is a resync blocks method. So basically we get last process block number for this chain, in this case Kusama. And then we do a bunch of RxJS magic. So if the block number is, if there is no block number, so basically we start processing from Genesis, then we return 0, instance of bn, big number of 0. And yeah, we process it just like we did before. We get block hash from block number, and then we get blocks by hash. So we use this old method we had before for processing new headers. And if it's bigger than, if it's not 0, if it's not undefined, I mean, and So we create a type of block number, and we add one, so we know which one is the next block number that has to be processed. And we get this finalized block number, and we calculate what is the difference, finalized block number minus next block number. And if the difference is 0, then we are in sync, then we don't have to think. So currently I throw error, and it works, but there must be a better way. I will do some research, but so far it works. So if difference is 0, then we stop resyncing, and we can just subscribe for the new blocks, same as we did before. And if
sorry, why do we have to throw an error? Why can't we just like return true or something?
Because it's observable, and we have to complete observable, unsubscribe from it.
Okay, I'm not really familiar with observables, so I'll take your word for it.
And yeah, if there is a difference, so there are still blocks to be processed, then we just return next block number, and we fetch hash from the block number, and then we get blocks by hash, same as we did before. Yeah, this is a little bit confusing part. I think maybe there is a better way, but I'm not that expert with RxJS either. So I will do some research on how to make it better, but so far, at least this works. And yeah, some minor refactoring here. I just removed this method to utils because it doesn't use any like this or any other things. So it just shapes the data. And yeah, I have added, so previously we were just logging the chain name and the block hash, and I have added height, so we can see in the logs that the order of blocks is maintained. What else? So this is a new method for the state module, get last process block by name. So we provide the chain name, and we get the last process block number from this JSON file. Yeah, and I moved this function to utils, as I mentioned. That's it so far.
I have a general question. Is it really possible to not use RxJS? I mean, to turn it as soon as possible into something like async iterator or just a promise and just write regular JavaScript? I just found it very difficult that all of those like combinators or whatever they are called, they're basically like somewhere in the library. You just need to know about them. Otherwise, you cannot really write anything. It's not like in like you dot map and you have autocomplete. It's just there somewhere. It's really hard to work with.
Yeah, it's like a library method, but Polkadot.js uses it under the hood. Even if you use like a promise API, it still exposes a lot of methods that under the hood they use RxJS, and it makes sense because promises are not very suitable, because you have to like there is a lot of like more difficult use cases than just simple promise like promise.all or promise raise. So I don't know.
I only see the major like feature is that in some cases you have subscriptions for multiple things, like new heads. It just emits new heads all the time. But in like modern JavaScript, you have async iterators for that, so you can just write a for loop and receive all those events, and it should be much more readable than like writing all those nested combinators. So maybe we can just get like this observable and then turn it somehow into async iterator and write regular TypeScript, whatever.
Yeah, I can do research, but yeah, it will require some refactoring because a lot of code currently depends on RxJS.
Right, that's fine. Just like for the future, because I don't think anyone besides you can currently read it, like properly. I mean, it's like I can read it, but it's like it's a lot of effort.
Yeah, it's I agree. It's quite difficult concept, all this functional reactive programming.
I mean, it doesn't have to be. It's just the library is designed such a way.
Okay,
Yeah.
well, we can add this
Let-
as an after, after we get a version 1 kind of optimization thing to consider.
Like one example of that, I was when I was writing this like blog downloading thing, I was actually doing some of the same calls that you do, like get finalized head, and it returns observable. And I saw that you are just awaiting on it. But when I write await in ID, it says that it awaits and gets observable again. It doesn't say that it gets actual value, because probably in types it doesn't extend promise or something. So like in IDE, support is pretty bad, actually. I understand it might compile and work eventually, but in JavaScript you can await non-promises, right? You can await a number, it will be a number, so it doesn't really care if it's a promise or not. So because of that, IDE is just confused.
Is there some special plugin for RxJS that will help interpolate that?
I don't think so.
Okay. Serge, anything else?
Yeah, I think that's it on my side.
Okay. Can you go to the board, please?
Sure.
Okay. So relayer startup checks, is that still in review or has that been merged? The bottom one on in review.
Yeah, I think it's already completed.
Okay.
So resync is still in progress. This one was deprioritized. And yeah, no other changes.
Okay, and then the save Kusama blocks in the file system, that's actually Nazar now, and that's in progress as well.
Should I reassign?
Yeah, I want just update it to Nazar, please. Yeah, thanks. Okay. So with the relayer resync process, it sounds like you've got that working locally right now?
Yes. Yes.
Okay. And is there anything left to finish it up before we can get that in review?
I think I can create a PR tomorrow. Yeah.
Okay.
I wanted to make it today, but I had flights, so I had no time to finish it.
Okay. Nazar, are you even bringing a laptop? Like, even though you won't be able to code, you'll be able to access like GitHub?
I have a phone. I can like click buttons on the phone, but it's hard to review on the phone.
Sounds like we need to buy you a laptop. Okay. So basically, yeah, I guess you can't really review code from your mobile phone. That would be pretty tricky.
I can try. We'll see how it goes.
Okay. Okay. So, all right, let's pause here, and then we'll talk about Nazar's part, and then we'll come back and talk about the whole kind of bigger picture of how this is coming together. Unless you have anything else you want to cover, Serge.
No, that's all on my side.
Awesome.
Just a quick question. Which ticket did you say was deprioritized? Was that submit blocks as binary?
Yes.
Thanks. I'm good.
Okay, Nazar, you're up next. Do you want to go through the Kusama?
I'm trying to share to find which window I need to share.
Okay.
Don't see it, which is strange. Let me try again. Yeah, I don't really see it in the list. Guess I'll share the whole screen. Is it working?
Yeah.
Mm-hmm.
Probably show it like this. Okay, so this is relatively simple script. It's 90 lines only. I try to follow the style that Serge did. So basically, we have two parameters: the source chain RPC endpoint. I'm using the local one because it's faster, and the target directory where we will store the downloaded blocks. Then we go to the chain and try to figure out what is the current finalized head and get the header to get the block number, and we store it in the variable. Then we subscribe to new finalized heads and update this variable as we are moving forward, because the progress will not stop as we are downloading it. I think this is leaking memory. I'm not sure why. It's confusing to me. So yeah, but it works. Doesn't leak too bad. Then we have some small metadata file which just stores a number, how many blocks we've downloaded. We update this from time to time. And then we have some log messages, and then we basically go from the block number that was archived to the finalized one, which is like moving target. And we basically download the block and its bytes, and then we just store it into the file system. We use the special path. So we basically take a number of the block, we slice it into chunks of at least 2 digits, and then we create a path nested file structure such that it will not have like millions of files in the same directory. And then you just write it. That's it. This is just for log output. And yeah, and that's it. So it will theoretically go on and on until it downloads everything. So I'm running the local Kusama node. This is currently syncing. It's like 3,700,000 blocks right now, out of 9 point something million. And I had the thing running locally, which was downloading blocks. I just stopped it. The problem is that it actually takes a lot of space when it's stored like this, due to the file system that has block sizes of 4K. So if you store a lot of small objects, it's a lot of overhead on the file system level. So we'll probably have to switch to RocksDB or something more efficient like this. But it does work. It started faster, then it got slower. I'm not sure entirely why. But it started from like 200 blocks per second, but then it got down to 90, 80, 70. Yeah, that's basically it.
Cool. That's awesome, Nazar. A couple of questions. So let me make sure I understand. So you're saying you're running, and actually, if you could share your screen, I still wanted to look at a couple of those numbers. So you're saying that you're running a Kusama node locally. So this is all on your machine, right? Okay, so you run a Kusama node, and then you sync that node from Genesis. And when you do that, what is it syncing with? Is it connecting directly into the Kusama peer-to-peer network, or is it going
Yes.
through like on?
It has 40 peers connected right now, so it's just syncing from everywhere. This is why it's faster.
Okay, got it. Okay, and the numbers that you were showing there, what's like 500 million or 600 million blocks in Kusama?
9
Like-
9 million.
9 million. And how much progress did it make since you started it up?
The archiving node, like Kusama node, is 3,800,000 right now.
Mm-hmm.
So it's over a third.
Mm-hmm.
And the the downloading script is much slower.
How long has that been running to get that far?
Docker PS, 6 hours, about 6 hours.
Okay, so we can realistically sync in about 18 hours, something like that, Kusama. Okay, and what's the progress? What's the percentage of those 3 million that are uploaded?
Downloaded.
Sorry, that are saved to the file system, the blocks.
I stopped at 1.6 million.
Okay. But you said that was slower than the sync itself.
Yeah, so there are two reasons. First, we don't use file system very efficient. It's quite naive way to do it. The other thing is we are just querying the block, waiting for block to be returned, and then we query the other one. We can probably query like a batch of blocks and write them as a batch. So I think we can make it much faster. I think we can archive like 500 blocks, maybe 1,000 blocks per second.
Okay.
It's just that getting the blocks somewhere where they are quickly accessible is the problem. That's why I'm running archiving node.
Okay. And if we use something like RocksDB or LevelDB, that's got a bunch of stuff around like log store compression under the hood that's running, which might
these
actually
data are they are actually like they have high entropy, so I don't think it would be possible to compress it that much. But we will at least not waste like 4 kilobytes for 200 bytes of data. It will be more like, I don't know, 300 bytes.
Why do you say waste 4 kilobytes? Is that because of the block size on the file system?
Yes.
Okay, got it.
And like we need to store an entry in like extend table in file system. There are like lots of things happening behind the scenes.
Okay, makes sense.
Actually, depending on how we want to retrieve them, we can theoretically just write them one after the other, assuming that we can like stream read it from disk and parse into separate blocks on the fly.
Right.
In
Just
that
write it
case,
as
we can
one
actually
file.
make it, yeah, very, very compact.
But if we write it as a file, then we have to have like a metadata of the offsets to parse it out, right?
Yeah, we could have like checkpoints, like every 100 blocks or 1,000 blocks, we can have like an offset, and then we can, if you need something in between, just go to the offset and read from there. That will be the most efficient space-wise.
Okay. Okay. Is this something that is I'm just trying to think about how this all fits together. So is it like we've got one process which is running this node and writing this to disk, and then Serge can just write the relayer so it starts reading from disk, and we can think of these as completely decoupled as long as they have a shared understanding of how the data is stored on the file system?
I think that's the point to discuss, because currently it's written to the file system as separate files. The nice thing is that we can potentially store the same way blocks from, let's say, Ethereum. And it wouldn't really matter for Relayer what those blocks are, where they come from. They're just files of binary data. But if you don't worry about that too much, we can then store it as like this contiguous file and then parse it on the fly, because we know how to parse it. We know the general structure of the block.
Okay. So this is something that we need to discuss in more detail at the offsite.
Yes, and there is actually one nice, strange design decision that Parity made about the block structure. If you look at how they're actually encoded and decoded, they can actually you can actually do it like two ways. They have a concept of opaque block, which basically like a vector of bytes, and they have structured block. And in the encoding, how it looks, it basically is a block plus justification from whatever signing algorithm you have. And the block itself is unsigned, so there can be some structure. And it actually starts with a prefix, which is compact scale encoding of the length of the bytes. And then there is the actual block itself, right? So if we don't care about the internals, we can just read this prefix and we know how many bytes we need to read after that. That's it. If we care, we can skip those bytes because we know how to interpret them. We can just skip them and then read the structure itself. So actually, when we use opaque block, we care about this like prefix. When we care about structure, we can actually skip that prefix and read the rest. So it's like basically like two kind of ways to interpret the data. And I think we can use that to parse substrate blocks regardless of what chain it comes from, basically. We don't need to know about all of those like headers and log items and everything.
Okay. Is this what are your thoughts on all this, Serge?
I'm still thinking on the general idea, but if you have a memory leak, probably you need some unsubscribed from observable. You need like take until or take something.
But I don't know how much I want to take. I just want to iterate until the script stops. I just want to throw away all the results.
Well, you need something, some way to unsubscribe.
Yeah.
Okay. Any thoughts on how to write it or read it from the file system from the relayer point of view? Like, I guess the next step now is we've got to plug this in so we can read and parse this and submit these transactions, right?
Well, I can try reading it like naive implementation, reading just from the file system and see how performant it is.
Actually,
But,
I think I can do the whole thing. Like if you give me a place like where I need to hook in, I can actually write a function that will read this thing. So I can write a function that will write it and the function that will read it. So you can integrate it with the rest of the relayer. I think it might be more time efficient.
Okay. Yeah, I'll think about it.
When you say read it, you mean like just to read it from disk, like an API to call the file system and return the block, or do you mean like read it and write the transaction as well?
No. So downloader will. I'm leaning towards having a continuous file. So I'll just write some kind of. I'll figure out the data structure, how the file will be organized, what will be the metadata, and how it's stored, and then I will provide like a function where Serge can basically call it, and it will like emit maybe observable with all of the blocks, so the layer can consume them and store them as if they were coming from the API. Just abstract away like working with the file system, like with file system. File
Then maybe it's reasonable to create like a separate class for that to deal with this big file of blocks. And
if you can create a file and define an API, I can write implementation for it.
Okay. Let me add a ticket for that.
Okay, so I think that would probably be a high priority to do that. So, but you're not really going to be able to work on that until after the offsite, right, Nazar?
Most likely.
Okay. Okay, so I guess that's something that we can discuss in more detail at the offsite, even if you can just have a draft API interface, Serge. That might be something that we could discuss when we get into the offsite itself, and when we get to that section on the relayer. Does that make sense? Okay. Okay, so I'm just trying to put all the parts together, make sure I understand this. So we're going to need to run on our droplet, like kind of at the end of the day, the way this is going to work is on our infrastructure, we're going to run a node for each one of these relay chains and parachains that's going to create a local, that's going to sync and then write all this data, probably a file for each chain, like one contiguous file for each chain. And then we will have a API for the relayer to go in and read this file and create these transactions, put these into the target chain, into Subspace chain. And I'm guessing that, I'm just trying to think ahead here. It's almost like we're going to need to, like these hosted nodes that we're running here, or these parachain nodes, they're going to need to kind of stay, like update, like maybe, I don't know, if we're going to want to run these all the time, or if we're just going to want to be able to like resync these. Like if we have like, version 1 of the testnet where we upload this data, and then later on we need to like regenesis or restart the testnet, then we need to have the data again, but the data will be larger by that point. Like for instance, when we go to mainnet launch, or when we go to incentivized testnet launch, we might want to preload like all the data for all the chains. So in some sense, like we've got to keep these backups, the source of the backups, kind of up to date periodically as well. It's not just like a one-time thing that we're just going to run this node once and download this data. Like we might
restart it from time to time and like continue from where we left off. And for like retrieving, I think we can actually like chunk the whole history in some like relatively big segments. And then you can actually have those segments as separate files, and you can actually create like a torrent file so someone can download it very quickly if they need to have like that history instead of syncing from very beginning themselves, assuming they are trusting us, of course. So we can like share the history that way.
When you say history, you mean the Subspace history?
No, the downloaded blockchain of, let's say, Kusama.
Okay. So kind of the same way people put the Bitcoin blockchain file system on BitTorrent.
But instead of storing the Kusama like RocksDB database that someone already do like for Prune database, we will store like the blocks themselves. So it will not
Nobody's
be possible
doing that
to
right
start.
now. Sorry, nobody's doing that right now.
The full history, no. I think it's just too big. But for our purposes, we just need an encoded block, and it effectively contains everything that's necessary. So that's what we care about.
And what's the advantage of putting it on BitTorrent for other people? Like, are we expecting other people are going to sync this history that we've got as well?
I don't know. Like, let's say Serge wants to start a local node from Genesis, and he needs the history for like testing purposes. How would he get the whole thing? One alternative is to run like I do Kusama node locally and wait 24 hours, or he can just open a torrent and download it.
Okay, but the torrent's only going to be on like, there's only going to be one peer hosting the torrent, right? Which is going to be our droplet.
Yeah. But it should still be faster to download a big file than to process all the transactions on archiving node. So should be time saving.
Okay. Okay. So okay, so after the offsite, so it sounds like we're pretty much at a stopping point. At least you are, Nazar. Serge, you're going to get this PR submitted for review, and hopefully get this public API defined, or started for how this, or it's not really public API, but the file system API, block storage API, and then let's see, Tuesday, travel day. So we've got maybe a couple days next week we can work on this, but it sounds like we've got to store the data properly, got to read the data properly, we've got to have resync working. So from your point of view, Serge, how much more time, like if we just say like days of engineering work from your point of view, how much more time do you think it would be until we can get to the point where where we can basically spin up a node on the testnet that has the full history of Kusama, and all the parachains, and the relayer. Like we've got everything preloaded, and the relayer is syncing these blocks in real time as they're coming in, and that's on our actual test net.
Well, I don't know what will be performance of the relayer, but I mean, the actual development initial stage, I would say development of the initial like implementation shouldn't be too long, but I think it is important to do proper testing to verify that we are not like skipping any blocks, that everything is in order, and you know, just double check before we make it public. And
Okay.
ideally unit tests too.
Okay. So if we just finish the integration work to get a proof of concept, how many more days do you think that will take you?
I don't know, maybe like a week.
And how long to do the testing?
Maybe, yeah, you can test forever, but maybe,
Well, how
yeah,
long till you would be happy with it?
one more week, yeah.
Okay.
But the problem with tests, that the more you test, the more you find issues, right? And you have to
Sure.
fix those issues. So
Sure.
it's a very rough estimate.
Sure. Well, this is a test net. It's designed to break. It's not
Right.
claimed to be production ready. It's not incentivized, so that's okay. It's not like we're launching a main net, so yeah. Okay. Okay, cool. Well, we can discuss this more at the offsite. Okay. Well, good. Well, I'm happy with the progress everybody's making. It sounds like this is really getting close to being finished. I don't have any other questions. Is there anything else you guys want to discuss on the relayer? Okay. Courtney, can you stop the recording, please?